welcome to my talk. My name is Christine Rüb, and I'm going to talk about our project where we moved our application from using Verity and Oracle to using Solr. I work for Juris GmbH, and what does Juris do is a German company that provides access to legal information and also about information about German companies. If you want to access the documents, usually you require a contract. We also have some public services where you don't need a login, like this example here, which we did for the Bavarian state. Our customers mostly are legal practitioners like judges or lawyers. So what kind of information do we have? There are laws, German federal laws, European laws, also of the German states. There are court decisions, again, federal court decisions, European and from the German states. We also have commentaries on laws because they are not easy to understand. We have journal articles and various other stuffs where I had problems to find a translation for. We have our own content, and we also present content from partners, publishing companies. We have the legal information. That's the most important part for us, is right now 6.5 million documents. The information about German companies is 28 million documents. I'm going to show you a bit what we do using our portal. This is the software we use for access to the documents. This access is personalized, and we have restrictions on the documents that each user can see. This restriction works for the search, for links in documents, and also for search suggestions. We have rather a lot of functionality, and we also produce a version on DVD. So here's an example for a user who may access 5 million documents. Should have tried that before. You can see it here. This is distributed in several kinds of documents. Rechtsprechung means court decisions. Gesetze, Verordnungen is laws. Kommentare is commentaries. So you only can search through the documents that are covered by your contract. And also the suggestions you get only consider documents that are covered by your contract. So this is example, the beginning of a file case number for court decisions. Then you get these suggestions. What could you mean? This is another example for a customer who only may see the German federal laws. This is about 416,000 documents right now. He only sees Gesetze, Verordnungen. And the suggestions now, I said this is the beginning of a file number. There are no court decisions in this collection, so we don't get any suggestions, but instead suggestions for what could be meant. No. We also have this personalization in the documents. The links in the documents only point to documents that the user may see. This is again the example with 5 million documents. The document is Article 3 of the Grundgesetz, the German basic law. That's one of the most cited documents in our system, and it's not easy to read. You see court decisions that cite this article, federal laws that cite this article, and laws of the states that cite this. If I go again to the other example, there are only links to other federal laws, because this collection only contains these. The links are also more dynamic than you see here. These are always the 50 latest documents of this kind. What we have in functionality, there are a lot of search masks, rather complicated ones, partially like this one. I don't think they are used very often, but they have to be there, where you can choose a lot of metadata you want to search through. And you can say, I only want laws that are valid today, only laws that will be valid in the future. I only want documents from the state and other such stuff. So we have a lot of these. There's also something like filters. So if you have your set of documents, you can restrict your search to a part of these documents. This is an example where the restrictions is on court decisions and also of European court decisions. And if you apply this filter, this is the example with the 5 million documents, you only will get through the search the European court decisions we have. Another important functionality for us is linguistic. In German, that's a bit more complicated than in English. There are different spellings. No. There are different spellings for words, like this here, for the and for words. It means the same. And also the male and female versions of documents can be quite different. And what you see here is that these four spellings, which all mean hairdresser, all have the same number of hits. There's also this function, you can construct rather long words in German. This used to be the longest word in German until a few months ago. That's the name of a law. It doesn't count anymore because the law is no longer valid. That makes it no longer the longest word. So this is what Google Translate claims the word to mean, Beef Labeling Supervision Delegation Act. What you can see here below this is we get 10 hits with Rindfleisch-Etikettungsüberwachungsaufgabenübertragungsgesetz. And if you add further words like Rindfleisch, which means beef, Fleisch, meat, you still get 10 hits in the end, which means that the parts of the word give the documents with this word as a result. We have more functionality that concerns documents. You can get, for example, the list of all versions that were ever valid for a law. The laws change all the time, at least in Germany. I don't know about other countries. And here you have a list of all versions that were ever valid. What we also have, I already explained, we have a DVD. That is essentially our portal with just a subset of the documents. We use scoring, sorting using metadata. We have faceted navigation. We have table of contents for norms, commentaries, and other kinds of documents. This information is always computed on the fly. It's nothing that is really stored as a document or something like that. We have links from one document to the next in a norm, for example, and we can show a version of the law that is valid today. What did we use previously? For search, we used Verity K2. Search means the search itself, but also linguistic. We exchanged that already with Verity. It was possible. Scoring, sorting, filters, all of this stuff. For links, and I use this word very loosely, it means essential relationships between documents using metadata. We used Oracle, for example, to construct a law as it is valid today. It can change every day, so we can't pre-compute everything here. The list of all versions of a law, it's the same. We don't want to index again every day. On the table of content. Also here, in the table of content, for example, only the valid documents are included. So the same applies. Our search suggestion with suggestions only for the documents that you can see was our own solution. What do we use now for search and for links? We use Solr 3.6 was released too late for our project. The search suggestion, we kept our own solution. We are in production since mid-January 2013. And for our customers, the functionality is almost the same. The reason for our migration was Verity, not Oracle. Verity is rather old. Has been no new development for quite some time. If you buy new hardware, it gets slower. I don't know why. And it has never been really stable. It's not that bad, but not really stable. We could construct documents that made it crash every 5 minutes. Why did we choose Solr? We started to look with a broader look. So we also looked at commercial solutions, and at least 3 companies said they could fulfill our requirements. But when we looked a little bit better at the functionality, what we saw is the linguistic was not exchangeable. And since this linguistic is for us a really important feature, that meant we couldn't use them. And also DVD was a problem because at least in some cases one could immediately see that the index would become too large. We wouldn't have been able to produce the DVDs as we did before. And also the other reason is that the adaptability. This morning it was called more control, what we liked. So, and what did we get in the end? The functionality remained almost the same, so it was possible to get the same functionality again. One exception is scoring. We get a better reliability in search, which means Solr does what we tell it to do. We got a very stable system. We weren't used to that before. The average running time for a search went down by a factor of 5, about, and the average running time for viewing a document went down by a factor of about 2. We used much less hardware to achieve this, and we got very little error messages from our customers. So, some decisions we made quite early in the project. We wanted to keep the functionality the same. That makes testing much easier. That means my life was much easier, and it was a technical project, so less involvement with other parts of the company or even customers. What we also decided is to review our architecture around the portal, the retrieval, database, and file system, because it was clear that our old architecture was outdated. We wanted to improve our indexing process. It just was too simple and needed sometimes manual effort. And we decided to implement the link functionality where we used Oracle before with the retrieval. The reasons for this is then we have one less technology to use, and there's less opportunity to get inconsistencies. Because if you have information in the index and in Oracle, it could be that they are not the same. What other decisions did we make? We only update our documents once a day. So that's not what many talks were on this conference. You want to index constantly. The reason for this is that if you are working in a session and suddenly your hit list changes, it's not something you really want to do if you're working. So for us, this is the right approach. There are 2 exceptions for this. The content of the homepage with just 5,000 documents. They are indexed regularly during the day. And also our test systems. Our test systems are not only for testing of software, but also for testing of documents when they are changed. And you don't want, my colleagues want to see their documents fast and not wait till the next day to test them, what they did. We also don't treat all documents the same. This concerns mostly performance, not availability or other stuff like that. Most important is the legal information, because we earn most of our money there. Next comes the information about German companies, and the next is the content of the homepage. What we also wanted to do is still use on the central file system and not move to local hard disks. So here's an overview how the processing of documents works at Juris. We have our own, you can view them as CMS systems for the management of documents, where documents are added, changed, sometimes deleted. I'm not going to talk much about this. Then there's something we call production. It's, among other things, it does the indexing, and then everything is consumed by the portal. So how does our architecture look like? Don't think it's very unusual, except for this central file system. There's the Juris portal that addresses the LAR nodes using the load balancer. We did this differently before. And the central file system, we have the documents. The documents are only read by the portal, and there are our indexes that are read by the Solr nodes. We have 4 indexes according to the type of information we have. There's one index for the link information, one for the legal documents, one for the information about German companies, and one for the homepage information. So how does our production look like? There are new and changed documents every day placed in the file system, about 20,000 on a usual day. Could be 2 million changed documents sometimes. These are read by our production and then put on the file system. The documents for the portal to read and into the indexes for the Solr nodes. You will see that the homepage index is missing here. We have a very simple scripting system there because it's much easier to do. So what we do after production, remember we only update our documents once a day. When the production is finished, everything is updated on the file system, the documents and the indexes. We produce a clone of this information that is then afterwards used by our system. Clone, I didn't know this 2 years ago what it really is. This is sort of a copy of files, except that nothing really is copied, only information about the files, which means it is very fast. It's space efficient. At the beginning you don't need much space because the files are not copied, and it's writable. So if something is changed either in the clone or in the origin, then you need space, but not before. And it's writable. We use this feature in our system. What is the advantage of this method? We can be sure that the documents and the index are always consistent. So we have the documents on the file system and we have the index, and we know that they are always the same. Else I think it would be more difficult to achieve this. So, for example, the 2 versions have the same permissions. Also, what is important to us is that documents that belong together have the same versions. For example, the documents of a norm. Else it could happen that we get a new norm and only half of the documents are there. Also, sometimes we have global changes in documents, and they should be seen at the same time and not earlier. I think I'm much too fast. So, as I said before, we only make 1 clone per day. So what does our production do? It's a Java application, Solr is integrated. This is the only part that really writes indexes. It reads new and changed documents from the file system, up to, say, 2 million documents per day. Deletions are also possible. As I said, only production writes the index. The other Solr nodes are only for reading. It extracts and transforms fields in the document. We have to do some transformation before the analyzer chain of Solr does anything because of the requirements we have. It writes the documents on the file system. It also ensures the right order of processing of the documents, because it can happen that one document is changed more often per day and you only want the latest version of it. It maintains some accounting information, so we can see what happened, what were the running times, which documents were processed. It extracts the information for our search suggestions. It also adds facets to documents as described in the database. This is information where we use sort of search requests to determine which documents get what facets. And it sends feedback about processing of documents back to our CMS systems after the documents have been published. And there's some more stuff going on. So what do we use? What cores do we have? You have seen already there are 4 cores. One legal information, one with the information about German companies, one about with link information, and one with the content of the homepage. So how large are they? We have legal information with 104 GB right now for 6.5 million documents. The documents about German companies are many more, but the index is much smaller. The search there is much simpler. And we have additionally 33 GB of for link information. And the document sizes are right now about this: 100 GB for legal information and 200 GB information about German companies. This is growing quite fast. What do we use on the hardware side? We didn't want to use sharding for our indexes because it's simpler not to use it. So we had to get a little bit more main memory, 128 GB right now. Use 6 servers with 8 cores each, but they are mostly idle. Everything is in cache always. So what did we do to get at this number 6 for our hardware, and also what do we need on our central file system? It was a totally new system for us, and we had no idea how much hardware we'd use. Luckily, we have a lot of historical data for the number and the kind of searches that are used by our customers. So we have this kind of information in our log files, extracted it, and used it for performance tests for search using scripts. We couldn't use the portal here because it would have been a bottleneck, a serious bottleneck. We also have information about document sizes historically, so we can estimate how fast the number and the sizes are growing. So we made some performance tests, multiplied this by 3 for the link information and the highlighting in the documents. It wasn't finished then. Made an extrapolation for the next 3 years, and the result was something like 1 to 2 servers mixed through. At 1, it's not that much, and because everything has to be fail-safety, we have 2 locations for our servers. We need 6 servers. Where, as I said before, we were a bit pessimistic here, and they are mostly idle. For the space on the file system, on our file system, we counted the clone as if it's an actual copy, so it needs space. Not as I explained before, because what can happen is that we have global changes in our volume that the production uses, and then it will need a lot of space. And also did this extrapolation for the next 3 years. So what we have on number of searches and document views per day, the maximum number I could find was something like 220,000 searches per day. and the number of documents something like 1.5 million per day. So this is what happened with performance, what you can see here. This is middle of January, where we went into production. This is Verity, starting here at Solr. This was the Saturday we changed. What you can see is that this is the average running time per day for search in the portal, not Solr or Verity. That's what the customer sees. It went down really nicely. What you also can see that there's a lot of variance here. There were other factors going into this that we couldn't see before because the running time was so high. These smaller variations weren't really visible. So what we get now is something like this, which is much lower than here. And this is the factor of about 5, I told you, about for the searches. Viewing documents looks a bit different. You don't have this drop here. It came later because these effects we had apparently affected the document views much more strong than the searches. And this is the running time we have now, around 200 milliseconds for a document. I think this one is, I should have deleted it. I think it's the warming up from, it's not a full day. It's part of the warming up. That's the reason why it's higher. So what do we get at performance at Solr? This is the excerpt of our running time. This is the average running times per minute. It's a typical example of how this looks each day. And we have something between 20 and 22 milliseconds per request. The running time here is much higher because we use more than one search in this case. And so I can show you this. This is our portal. Where's my mouse? Here. No? They usually use the same words. Nothing very really legal about this. And what you get is you get the hits for each of the words. You get the distribution among the document types. You get also here the navigation and the hit list, which means there's much more than one request for Solr. I also said we have a DVD. There was one problem when we switched from Verity to Solr, is that the index became larger. I think mainly the reason is that we used the better linguistic we had online before, but never on DVD, because we knew this effect. Verity had its own linguistic that wasn't very good, but good enough for DVD. No. So what did we do? We reduced the schema file to the absolute necessary fields required on the DVD. I have shown you the search mask we have. Our schema file really is large, several hundred fields. So we reduce this to the absolutely necessary part. The highlighting of search words and documents also, we use our own highlighter, which is then dynamic, because the usual one uses too much, makes the index too large. And for the really large DVDs, we had to use compressing of the index, and then it has to be copied and decompressed at installation time, which I think we had to do 1 year earlier than we would have to do it with Verity. So it's only a bit earlier, because the number of documents is always increasing on DVD. So what did we miss? What were we used from Verity and didn't get anymore? Verity could use make of the DOM structure of the documents. For example, this is the easiest one. you want to have X contained in field 1 and field 1 should be inside field 2. That is rather easy to replace. This is a bit more complicated. You want X contained in field 1 followed by Y, and all of it should be contained in field 2. We have, there's even one version we use that's more complicated, where there are range queries included here. And for this, we use span queries plus regular expressions. That's the solution we came up with for this. What also was possible with Verity, we could add facets to document without indexing the whole document. It's not possible with Solr. It's not a big problem because we have our production process, and what is done here, that this is information about that is in a database where we add facets to the documents. It reads the documents again, adds the information, and sends it again to the index. And for the hierarchical navigation, our navigation is too big to load everything, all facet information, so we added some information about levels to the entries. So what could we not use? I didn't know that this is the beginning. Search suggestions, because of the personalization we have. I don't know how we could change that, but our old solution is fast and has no problems. It works with the same. It's fast because, as with Solr, everything is in memory, so we still use it, no problem. And we couldn't use the synonyms of Solr because we have synonyms between one and many words. So we just put the synonym list on the portal site. Not a big problem. So what did I like most? The first is the stability, because we won't use this with Verity. The performance is also for search, especially. The viewing of documents were never a problem. It was always fast enough. The performance is really nice. The adaptability, and I like schema files because it really gives a lot of control about our search results. That's something we had problems with Verity, that we had to do a lot of hacks to get it to something similar to this, and it wasn't the same. So I'm again back to what did we achieve. The functionality we could keep almost the same, except for scoring, and we didn't reprogram all of the errors we found with Verity during testing. The reliability is better. Our system is now very stable. Our system operation group was very happy when we went in production. The average running time has been reduced by about a factor of 5 for search. For viewing of documents, it was reduced by a factor of 2. We used much less hardware, and we got very little error messages from customers. It means less than 10, which for one means we made a good job with programming and testing, but also that the basis is really what we need. So it was faster than I thought it would be, so we are already at the questions. Do you have any questions?
And the DVD version, does this mean that you install the system on the customer PC?
Yeah.
Okay. So you're running a Tomcat then?
Yeah, it's a Tomcat. That's the same as before, only that we had no also Solr. No Oracle. The links were they were expanded before the production. You don't have dynamic on the DVD, so you can do that. There's only the documents that like they are today. There are no changes, so you can put this into the documents. No Oracle. We have a small database for other purposes on this for notices to documents, but no Oracle. Again, thank you for your time.